This is homework help with Jen. We're doing chapter 6, problem 75 in the 9th edition and 73 in the 8th edition. This is a Hess's Law problem, and it's a really big Hess's Law problem. What I've done is I've copied out all the equations from the textbook along with the final equation that we're working towards. Okay, and I have found my reactants and products. Okay, so what I've done is I've circled all my reactants that I need in red and the products that I need in blue. That's going to give me a starting point to work with. All right, so first of all, it says that we need 1 mole of calcium carbide in our final reactants, and here I have 1 in my products. So what I'm going to do with this first equation is I'm going to flip it. Okay, I'll go through at the end and kind of write things down. The next thing that I see is that I need 2 moles of water into my reactants. Now this is where it gets tricky because I have 1 mole of water in my reactants here and 1 mole in my products. I need 2 in my reactants, so I probably need to flip this one, but let's come back to that in a minute. All right, then I need 1 mole of calcium hydroxide in my products, and I have that there. So see that 1 mole? That means that I'm probably going to do nothing to this equation. All right, and then last but not least, I have C2H2 as a gas down here, and I need 1 mole of that in my products, and here I have it in my reactants. So this one I think will work lovely if I flip it as well. Okay, that means that everything else is going to end up being used to cancel things out. So the equation that I'm not changing, I'm going to circle that so that I realize that I'm going to be using it. Now let's start manipulating some of these. All right, I have to flip the top equation. So I come down here. We're going to make this 1A, since it's the first equation flipped, and we'll call it CaC2 solid yields calcium solid plus 2 carbon graphites. Okay, and now we have to flip the sign on delta H to be positive 62.8 kilojoules. All right, the next thing that I need to do is I need to flip my fourth equation. So I'll go ahead and call that 4A, and I'll flip it over, and it gives me H2O liquid plus 2 CO2 gas yields C2H2 gas plus 5/2 O2 gas. Now since I flipped it, I need to flip my delta H, so that becomes positive 1,300 kilojoules. All right, now what I need to do is I need to use my other equations to start canceling things out. All right, so let me find again my reactants are here, okay, and here, and then up here, okay, and then my products are here with my calcium hydroxide and here with my C2H2. All right. The rest of this all needs to get canceled out. So let's see what we can start working with so far. Okay, here I have 2 graphite carbons here. So again, let me go ahead and kind of line these out so that I don't try to use them again. All right, so here I have 2 carbon graphites that I need to cancel out. All right, and up here in this equation, I only have 1. So in order to cancel that out, what I'm going to do is I'm going to multiply this through by 2 all the way across. And I'll cancel it out because I'm going to do that right now. So we'll call this 5A. And that tells us that we have 2 carbons in graphite form plus 2 O2, the gas, yields 2 CO2 gas. And my delta H is then doubled. So delta H becomes 393.5 times 2, negative 787, sorry about that, kilojoules. All right. Okay, so I've lined that out. Now let's see what I can cancel out. Well, now I can cancel out the graphites. Okay, those are gone. Yay. Oh, and now look, see, I have 2 CO2 here and 2 CO2 here, so I can cancel those out as well. This is going just swimmingly. All right, now I have some calcium solid that I need to cancel, and I have some calcium oxide solid that I need to cancel. That was the equation that I didn't change. And I have 2 oxygen gas units here and 5 halves units here that need to get canceled out as well. So let's look at what I have left over. Okay, here I have a calcium in my reactants and a calcium in my products. Okay, 5 halves is the same as 2.5. I have 2 oxygen units here and half of an oxygen unit here. That becomes 2.5. And I have calcium oxide here and calcium oxide here. So I am going to be able to use this equation without altering it as well. All right, so again, let me go through that to show you. So I have a calcium here that gets canceled with a calcium here. Okay, I have 2 O2 and a half of an O2 cancel against my 2 halves O2 here. All right, and then I come back up here and I have the calcium oxide here that cancels with the calcium oxide there. Okay, I have canceled everything that I need to cancel and done everything that I need to do. Okay, so now my delta H for this final reaction is going to be the delta H for 2 plus the delta H for 3 plus the delta H for 1A, for 4A, and for 5A. All right. So I'm not going to rewrite all those. I'm just going to go through it though. So I have negative 635. Oops, here. 635.5 negative. I have to do that backwards on my calculator. Plus a negative 653.1. Okay, and now plus 62.8 plus 1,300. I think I added those wrong. Okay, give me a second to do this without talking. 635.5 negative minus 653.1. Okay. Plus 62.8 plus 3. Okay. Okay, and then minus 787. Sorry about that. I probably should have just written them down. But oh, so when I take a negative 635.5 and add a negative 653.1 to it, and then a positive 62.8, a positive 1,300, and a negative 787, I get an overall delta H value of negative 712.8 kilojoules. And that was a long Hess's Law problem.